In second part of the lecture on Hermitian operators, now we will discuss some important problems to clarify the concept which we have studied in the first lecture. So let us start with some problems. The first problem I would like to solve is so that if two Hermitian operators commute, then their product is also a Hermitian operator. Now we will solve this problem. What this problem states? Actually, we have to show that if there are two Hermitian operators and both of the operators commute with each other, in that condition, the product of those two operators will be also a Hermitian operator. So let us consider there are two Hermitian operators. Let A hat and B hat are two Hermitian operators. And as the problem says, these two operators commute. What does it mean? Then we have given that A hat B is equal to B hat A as the operators commute. In this condition, we have to show that the product of A hat times B hat is a Hermitian operator. This is what we have to prove. So let us see how I can prove this very important fact. To prove this, let us consider the two eigenfunctions, or you may say eigenkets, psi1 of x and psi2 of x. Let psi1 of x and psi2 of x be two functions. You may say arbitrary functions. We consider it. Now, we evaluate a particular integral. Consider an integral minus infinity to plus infinity psi1 star of x AB A hat B hat psi2 of x dx. Actually, we want to simplify this integral, remembering that both of the operators a hat and b hat are Hermitian. So, as a hat is a Hermitian operator, So what we can write? We can write that integral minus infinity to plus infinity psi 1 star of x a hat b hat psi 2 of x dx equal to, since a hat is a Hermitian operator, so we can write it as integral minus infinity to plus infinity psi 1 star of x a hat b psi 2 of x dx, and this may be written as integral minus infinity to plus infinity, since a hat is a Hermitian operator, as I have mentioned here. So you know from the definition of Hermitian operator that this operator may be associated with first function psi 1 star of x or the second function b hat psi 2 of x. So let us link this operator to the first function. So what will be it? It will be a hat psi 1 star psi 1 of x star and b hat psi 2 of x dx, and say this is equation 1. This is b hat. Now it is given in the problem that the operator b hat is also Hermitian. Again, b hat is also Hermitian. So what we can write then this integral? So we can write minus infinity to plus infinity a hat psi 1 of x star b hat psi 2 of x dx. This equal to integral minus infinity to plus infinity. Now we can link this operator b hat to the first function, and so this will be what? This will be integral b hat a hat psi 1 of x star psi 2 of x dx, and say it is equation 2. So what we see from equation 1 and equation 2? We see that from these two equations we can equate this integral to this integral. So now equating these two integrals we will get. So from 1 and 2 we have integral from minus infinity to plus infinity psi 1 star of x a hat b hat psi 2 of x dx, and this equals integral minus infinity to plus infinity b hat a hat psi 1 of x star psi 2 of x dx. Or in bracket symbol we can write these integrals in LHS and RHS as what? We can write this is bracket of psi 1 a hat b hat psi 2, and this equal to bracket b hat a hat psi 1 psi 2. Say this is equation 3. But as it is given in the problem that the operators a and b commute with each other, so we know that a hat b hat is equal to b hat a hat. So what we can write now the equation 3. We can write it as bracket psi 1 a hat b hat psi 2 equal to bracket a hat b hat psi 1 psi 2. And what this property refers, from the definition of Hermitian operator we know that if the product of the operators a and b, that is a hat b hat, is linked to psi 2, and then we take its scalar product with psi 1, and if it is same as the result when we link this operator with psi 1, then the operator a hat b hat will be a Hermitian operator. Hence from this result we can say that a hat b hat is a Hermitian operator. Hermitian operator. So I hope you have understand that if two Hermitian operators commute, then their product is also a Hermitian operator. Now we will take another example which is also very important. You are familiar with the momentum operator And now we will see that momentum operator is actually a Hermitian operator. So our second problem is so that the momentum operator Px hat equal to minus IH cross d dx is a Hermitian operator. It means we have to show that this momentum operator is a Hermitian operator. We can solve this problem in very easy step by following the property of Hermitian operator. So, to prove this operator as Hermitian, let us consider two arbitrary functions just like in previous problem. So, let psi1 of x and psi2 of x be two arbitrary functions. These are functions of x. Now let us evaluate the quantity psi1 px hat psi2. We know from the definition of a scalar product that this is in integral form as integral minus infinity to plus infinity psi1 star of x and p x hat psi2. But what is px hat? We know it is momentum operator and this is defined as minus IH cross d dx. So this will be minus IH cross d psi 2 of x dx. And as minus IH cross is a constant factor, so take it out of the integral and our result will be what? This is minus IH cross minus infinity to plus infinity psi 1 star of x d psi 2 of x dx and dx. Now we will integrate this, or you can say we will evaluate this integral by integrating it by parts. So let us integrate the RHS by parts. Integrating by parts. This is equal to, what will be it? This will be minus IH cross you know from the rule of integration by parts, we will write the first function, this is psi1 star of x into integral of second function. Second function is what? This is d psi2 by dx, and integral of this with respect to x will be simply psi2 of x. So this is psi2 of x, and the limits are minus infinity and plus infinity. No, there is minus, integral from minus infinity to plus infinity. Now we write a differential of first function, and first function is psi1 star of x. So what will be this? This will be d psi1 star of x dx times integral of second function, and integral of second function will be psi2 of x, psi2 of x dx. So this is, take it small bracket. Yes. Now, as a wave function is square integrable, so it must vanish at plus minus infinity. We know psi1 of x and psi2 of x, this is 0 at x equal to plus minus infinity. You have seen it in the definition of Hermitian operator too. And this is due to the fact that the wave functions are square integrable. So in this condition, what will be this first term? This first term will vanish at the limit x equal to infinity. Psi2 of x is 0, and so this will be also 0. So the first term will be 0, and the result left to us will be what? So we will have bracket psi1 px hat psi2 is equal to, see, this is 0, so the remaining term is this much, and so this minus and minus will be plus, and this is I h cross integral minus infinity to plus infinity d psi1 star of x dx psi2 of x dx. Say this is equation 1. Now we will evaluate the scalar product when this operator p hat x is operated on psi1. So let us evaluate this quantity. Px hat psi1 psi2. From the definition of a scalar product, what you will write it? We will write it integral from minus infinity to plus infinity px hat psi1 of x star times psi2 of x dx. And now write the meaning of this operator px hat. This is in fact minus I h cross d dx. So what will be it? it is minus integral minus infinity to plus infinity. This is minus I h cross d psi 1 of x dx star psi 2 of x dx. And what will be this result? Actually, complex conjugate of minus I will be plus I. So the result will be what? So this will can be written as bracket px hat psi 1 psi 2 equal to I h cross integral minus infinity to plus infinity d psi 1 अरे इसमें तो है कमेंट उमेंट आने लगा, वो जो हम लिख रहे थे वो गायब हो गया।
आपको यूज करना इसको हटाना पड़ेगा। अच्छा बताइएगा, याद दिलाइएगा जब हम एडिट कर रहे होंगे
उस समय वो आ जाएगा ना। d psi 1 star of x dx psi 2 of x dx. Say it is equation 2. So what you see from equation 1 and 2? You may you can see that from 1 and 2 we have bracket psi 1 px hat psi 2 equal to bracket px psi 1 psi 2. So this result shows the very important property of Hermitian operator, and this is the condition which, when satisfied, then you call the operator Hermitian. So in this condition we can say that px hat equal to minus I h cross d dx is Hermitian. This is Hermitian operator. One thing I would like to mention here, that if we check the operator I d dx, is Hermitian, and I leave it for an exercise to you. You must follow the step uh, as I have followed in this problem, and you can see that this operator will be also a Hermitian operator. So now we will solve another important problem. The third problem we take for illustration so that the operator d dx, only d dx, is not a Hermitian operator. I have written in the previous problem in note that I d dx will be Hermitian, but only this differential operator d dx you will see that it is not a Hermitian operator. And we will solve this problem by following the steps as in previous problem. You can see it in a very easy way. So let us say this differential operator is a hat. You may write a hat equal to d dx. We suppose it. So now what will be bracket of psi 1 a hat psi 2? Here we have also assumed the two arbitrary functions psi 1 of x and psi 2 of x. So from definition of a scalar product, we know it will be integral from minus infinity to plus infinity psi 1 star of x a hat psi 2 of x dx. And now we will substitute the meaning of a hat. This is in fact d dx. So this result can be written as integral from minus infinity to plus infinity psi 1 star of x d psi 2 of x dx and this dx. Now we will integrate this by integration by parts. So what will be this? We write actually it first function. Our first function is psi 1 star of x and integral of this second function, and the integral of the second function d psi 2 by dx will be psi 2 of x, psi 2 of x, and the limits are infinity and minus infinity. Now minus integral of, now the formula says differential of first function. So what will be this? This will be d1 d psi 1 star of x by dx times psi 2 of x dx. Now, as I have mentioned in the previous problem that at x equal to plus minus infinity, psi 1 of x equal to psi 2 of x, and both are 0 because these functions are square integrable. So this first term in RHS will be 0, and we are left with the result what? Our result will be, so our result is bracket psi 1 a psi 2, a hat psi 2, and this is actually equal to what? This will be minus integral from minus infinity to plus infinity d psi 1 star of x by dx psi 2 of x dx. Say it is equation 1. Now we will simplify bracket a hat psi 1 psi 2. Again, from the definition of a scalar product, we know it will be integral from minus infinity to plus infinity a hat psi 1 of x star psi 2 of x dx. And now we know this a hat is nothing, this is simply d dx. So this will be integral minus infinity to plus infinity d psi 1 star of x dx psi 2 of x dx, and it is equation 2c. So what you see from equation 1 and 2, this quantity is minus this much, but this quantity is plus this much. So from 1 and 2 we see that bracket psi 1 a hat psi 2 is not equal to bracket a hat psi 1 psi 2. These two are not equal, and but we know if a hat will be Hermitian, then this should be equal. It means a hat, which is in fact d dx, is not a Hermitian operator. Hence we conclude that hence a hat equal to d dx is not Hermitian. So these were the some important examples on Hermitian operator, and I hope you have understand how we prove a given operator is Hermitian or not. In any problem you can follow this step. So this is all for today.